Okay, welcome back. We're going to continue our notes for graphing rational functions. So what we ended up doing yesterday was we started to piece together these rational functions by first simplifying the function, finding the horizontal asymptotes and vertical asymptotes, okay? So now what we're going to do next is we're going to try to finish up 4 through 7 for each of the 3 examples. All right, so let's start with the first example that we had. Now we simplified. We didn't have to simplify because it was already in simplest form. All right, so we found the horizontal and vertical asymptotes. So now we're going to do the fourth part, which is identify any discontinuities or holes. Okay, so here we ask ourselves for discontinuities. Or what we call holes in our graph. We ask, did we cancel anything out when we simplified? When we simplified. So when we looked at our function, we didn't simplify it. It stayed the same because it was already in simplest form. So the question is, did we cancel anything out when we simplified? No, we did not. So there are no holes or discontinuities. Okay, next part. We're going to find any x-intercepts. Okay, so for number 5, to find x-intercepts, what we do is our numerator, we set our numerator equal to 0. All right, so let's see. Our numerator here is x minus 3. We set it equal to 0 and we solve for x. All right, so here we know that our x-intercept is at x equals 3. Okay, we could write that as an ordered pair. If x is 3, our y will be 0 for our x-intercept. Okay, so we got number 5 done. So now we have to find any of our y-intercepts. Now for our y-intercepts, what we do is we plug in x equals 0 to our function. All right, and we could use a simplified function. If we did simplify it, in this case, we just have x minus 3 over 2x plus 7 was our function, and we're going to plug in x equals 0. Okay, so we have 2 places here to plug it in. So then we have 0. Ooh, that's not a 0, that's a g. Okay, so we have 0 minus 3 over 2 times 0 plus 7. Okay, so here we have negative 3 on top, positive 3 or positive 7 on the bottom for our denominator. So that means our y-intercept is y equals negative 3 over 7. And we could also write that as an ordered pair. Our y-intercept is here. Our x value is 0. Okay. All right, and then we're going to use all this information to graph our functions. Okay, so we don't have any discontinuities, so cool. We don't have to put any holes in our into our function. So here is our graph, and we're gonna put a point. We're gonna mark a point at 3, 0. So 1, 2, 3, 0 right here. This is our x-intercept. We'll change the color to do our y. So our y-intercept is at 0, negative 3/7. So 0, negative 3/7 is maybe about right there. Okay, So our next step, which would probably be the next video, would be to find points and figure out what the function looks like here, okay? So we still have a little bit of space here to do that. We'll probably end up doing that in the first video, just finishing up our graphs. So far we have our asymptotes, horizontal, vertical asymptote, vertical asymptote, x-intercept, y-intercept. Okay, so far so good. It's looking like a good graph. Now let's go to the next one, next example. We're going to do the same thing. 3, identify any discontinuities. All right, so let's do that. 4. So, did we cancel anything out when we simplified? Okay, when we simplified, did we cancel anything out? Yeah, we did. We had this guy right here. All right, so what we're going to do is, that would be considered our discontinuity. Okay, so yes, we did cancel something out. We canceled out the x minus 3. All right, so if we have an x minus 3, we have to set it equal to 0 and find out where this discontinuity would be. So it's at x equals 3. I can actually plug it back in. This was our simplified form here. Okay, so what I'm going to do is I'm going to plug in x into this guy right here and find out what the coordinates are for this discontinuity. So 5 over 3 minus 5 is equal to, okay, so there we go. We can also rewrite this as negative 2 1/2. Okay, so that means our discontinuity when x equals 3, I can write it as an ordered pair, our y would be negative 1/2. So this is where our discontinuity is, and we can put that on the graph. All right, let's go to the next part. The next part is our x-intercepts. To find the x-intercept, we set our numerator equal to 0. So here we set our numerator equal to 0. All right, so let's see. We have our simplified function here. Now, can we set a 5 equal to 0? Well, no, 5 is not equal to 0. You cannot set it equal to 0. So what does that mean? If we can't do it, that means there is no x-intercept. Okay, and that's okay. There doesn't have to be one. Yay! Okay, let's go to the next one. Number 6. We're going to find our y-intercept. And to find our y-intercept, what we do is we plug in x equals 0 into the function. All right, so let's do that. We have x, oh, I'm sorry, not x. Let me erase that. Our function, our simplified function is 5 over x over 5, and we're going to plug in 0. So here, 5 divided by 5 is 1. Okay, so when we plug in x equals 0, we get negative 1. Okay, so this is our y-intercept. Is at y equals negative 1. Okay, we could write that as an ordered pair. All right, so let's put these on the graph. We have a hole at 3 and negative 2.5. So I'm going to go 1, 2, 3 down to 2.5. 1, 2.5. Oh, I don't fill it in. It's a hole. It is open. Okay. And then we do not have an x-intercept, so we just leave that part alone. Okay, so it's not gonna cross the x-axis anywhere. And then we graph our y-intercept 0, -1. So this is where it crosses the y-axis. Okay, cool. Now let's go to the third example. Same thing. All right, so number 4, did we cancel anything out? Yes, we did. What did we cancel out? We canceled out the x plus 5. Let's set it equal to 0. So here we have a discontinuity at x equals -5. And to find where it is, the ordered pair, I'm going to plug it into the simplified function. So I'm going to plug in here -5, take away 5 over 4. This gives me -10 over 4, which is equal to -5 over 2, or I can rewrite it as -2 1/2. Okay, so we have an ordered pair here for our discontinuity at -5, -2 1/2. All right, now we're gonna find our intercepts, our y and our x-intercepts. So let's start with our x-intercept. And we do that by setting our numerator equal to 0. Our numerator here is x minus 5 is our numerator. So we set that equal to 0. Okay, so we have a x-intercept at x equals 5, and we write that as an ordered pair of 5, 0. Okay, cool. 6. Okay, to get our y-intercept, plug in x equals 0 to the function. Our function is, our simplified function is what I'm using, x minus 5 over 4, and I'm going to plug in x equals 0. So here I have -5 over 4, or I can write it as 1 1/4. Okay, so that is my x, or my y-intercept, right? I could write that as an ordered pair when x equals 0, y is -1 1/4. All right, so I can put that on the graph. Okay, so I didn't have any asymptotes. I do have a discontinuity at -5, -2 1/2. So let's put that in. 1, 2, 3, 1, 2, 3, 4, 5, -1, -2 1/2. There's my discontinuity. It's open. Okay, I have a x-intercept at 5, 0, 1, 2, 3, 4, 5, 0. And I have my y-intercept at 0, -1 1/4, which is about right there. Okay, and we have to see what that's gonna look like. All right, so far we have our kind of skeleton of each of our functions. So we found out where our asymptotes are, if we have any discontinuities, our y and our x-intercepts. Okay, next we gotta just figure out, or kind of fill in the rest. So we're gonna plug in points. Okay, and we're gonna kind of give a rough estimate of to what our function looks like. Okay, so that'll be the last video. And the last video I will give you right before I give you a few problems that you have to graph. It's gonna be 3 examples just like this. You will have to do steps 1 through 7 for each of the 3 rational functions in order to graph. Okay, so see you on Monday. Bye.